So what I'm going to do is I'm going to show how and why we might be creating a sampling distribution for sample slope. So what I have here is data where we've got 99 students, we've measured their GPA, and we've measured their ACT score. So we can look at that in a table, or we could look at that in a graph, where GPA is the explanatory variable, ACT the response variable. We could, and if this is our whole population of data, which it is at this point, what we're going to do is we're going to look at the population regression line. But usually we don't have all of this data, and we might just want to sample a small group of students. So what we can see here is the actual population parameters, which would be population slope, 5.17, and population y-intercept, 6.7. It also gives us r-squared, telling us that 61% of the response can be explained, the response, which is ACT, can be explained by this regression model based on GPA. So let's do some sampling. So we're going to sample just 9 cases. So sample cases. Let's take a look at what just happened. And a table is not always a good way to look, which is why we have graphs. So I'm going to see what that scatter plot looks like of my sample. There they are. I might be interested in the least squares regression line, so that I can see the sample slope. So the sample slope here, which we might use to estimate the true population parameter, we can see it's actually quite close. So the sample slope in this case is 5.11. Now, anytime a researcher does this, this 5.11 is just an estimate of this true slope. So what we might want to think about is what is the sampling distribution of this statistic? And this statistic is B, which is sample slope. So what we can do is we can set up a measure in our sample. And let's say that I want to measure the slope, or B, sample slope. Now, in Fathom, it has a formula. And I can just go down to statistical, 2 attributes, and it looks like linear regression slope. It's there. And it tells me that I need to use the predictor, comma, response. And the easiest way to do that is just to scroll up and double click. I'm using GPA to predict ACT. I'm going to apply it. Yep. And I can see that 5.11 is measured there. And then I want to tell Fathom to do this many, 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 many times. So what I'm going to do is I'm going to start collecting these measures, collecting these sample slopes, and see what kind of distribution they have. So Fathom, we just right-click on the collection, collect measures, and you can see each time it's doing this, and you can see that I had meant to only do 9 samples, so I'm going to change that. I'm going to go back to my collection, sample cases. I want 9, and I do not want them to be replaced. And I'm going to turn off the animation so that we don't have to watch each one come in, because I'm going to do many, many of these. So now we can see, yep, now I've got a sample size of 9. I'm going to delete this and show you again. So I'm collecting those measures of sample slope. Let's see, should allow me to collect measures. And you can see it's taking a new sample of 9, calculating the sample slope. And let's see what came in. So I'm going to look at it in a table. It only did 5 of them. And then I can bring down a graph. And the questions we might be thinking about is, what would be the center of this distribution? What would be the spread of this distribution? And finally, what would be the shape of this distribution? So I'm going to collect many, many, many measures. So this is my measures inspector. It only did 5. Let's try to do 100. see what happens. Turn off the animation, and let's replace what's there so I know that there's exactly 100. And so what we're seeing happen here is we have the sampling distribution of the sample slope. And so here's 100 measures. I might be interested in what is the mean, what is the standard deviation, and I can actually do that, okay, by just pulling down the summary table and bringing down this attribute. It's got mean, so it's going to be the mean of the sampling distribution of sample slope. I can add the basic 5-number summary, and I can see the standard deviation there. Okay, maybe I didn't want to do that. Maybe I just want sample standard deviation because I want center, and I want spread, and this is just S, open parentheses, and it knows what I want. It knows that I want B. You can see it here. I could put that in there if I want it. So the center and spread of this sampling distribution. Okay. Now, I might want to do this many, many, many times. So let's do 400 more times. Let's not replace. So now I'll get 500 total. So we might be thinking, is it going to be symmetric? Is it going to be skewed? What might the center be? Is it getting more spread out? Or is it normally distributed? Are most of the data values within 3 standard deviations, or within about 3 standard deviations? Because that should be about 99.7% of our data. And it looks about right. If I subtract 4 minus, actually, it looks pretty normal to me. So I'm noticing that the shape is normal. The mean looks to be estimating about 5.91. And I could check that with the actual 4.91, the true slope. And so the more samples we take and sample slopes we measure and then record them, the closer we're going to get to this population parameter we're trying to estimate, because it's an unbiased statistic. So that's how we would create the sampling distribution of sample slope. Good luck.